Thank you. Um, Good afternoon. I'll try to um, uh, parang spare some time later, no, for questions. Anyone like not using Python for say, hindi. Any one of you who is not working on like software development? I mean, hindi gumagawa ng websites, ng systems, etc. Because that's really like the population of my talk. It's more on data processing. I don't know if I'll be flashing some idiotic code, so um, there. Are you all familiar with big data? Have you heard of that one? Okay. Okay. So I'm Rick, as what the MC has introduced. So you can follow me in GitHub. I also try to regularly blog at Medium. I'm posting mostly related to PySpark and big data and Python there. Mostly notes on development on Spark. I'll try to cover these topics. So I'll introduce the intersection of big data and data science using Python, and hopefully give light on how this amazing tool called Spark, PySpark, to enable collaboration between data science teams and DevOps. And have you heard of pandas? Anyone using pandas here? Okay, so some people there. So yeah. Just to like introduce PySpark easier, so I'll compare it to pandas. And the usual question when doing a talk on PySpark is that, can you use scikit-learn with PySpark? Have you heard of scikit-learn aside from those people on this side? There. And then yeah, I'll entertain questions. There. So this is a huge ecosystem of big data providers, solutions, etc. It's like if you're gonna read about big data, it's more parang ano na siya eh. It's bordering to hype. Some companies will be doing big data even if they don't have big data, or even if they don't need big data, no? Just to be on that big data password. No? So this is the whole ecosystem and providers there. The most popular that are using open source, that's gonna be Cloudera, Hortonworks, and MapR. Of course, there are other providers there. So there are, I don't know if most of you are familiar with this. The most popular big data tool for now, well, at least for storing data, is the Hadoop ecosystem. So HDFS, or Hadoop, has been developed by Yahoo. So if you follow the Yahoo machine learning group, they are still churning out lots of amazing tools for big data and data science, even if Yahoo, the company, is kind of like in rumbles now. But the data science team, the machine learning team, they are still producing lots of new tools. Hadoop has been like for a long time already. Almost all the popular data processing tool would be using this. Google, so once those companies were able to use or store big data, not using the usual data warehousing tools of RDBMS, so that's using Hadoop. The problem now is how to process data. So, and Google came out with a very amazing tool back then, and it's called MapReduce. You imagine the Hadoop ecosystem, the file system, like this. it replicates, it chunks, or it breaks down your data into 64 MB chunks, and then triplicates those chunks on every node of your cluster. So usually a Hadoop cluster would be like from 10 nodes to, I know a company in here that have like 120 nodes. So every chunk of 64 MB is being replicated on those nodes. And you imagine MapReduce as it reads the data from any of the node. So that's one chunk. And then it reads the first line. So it reads per line. Reading per line uses the map part. So that's where you apply, say, if you're familiar with in Python, you can load a CSV, right? So you load a CSV either line by line. So you first load your CSV and then read the first line, and then you can do something on that line. That something is called the map in MapReduce. So since it can be done on a chunk and per line, you can do that per node. Okay. So the map part you can do per node. The problem is when you would like to say compute the average or something. If you want to get the result, it's inevitable that you're gonna do is collect whatever you have done on those worker nodes, as they call it. And that's the reduce part. So that's why it's called MapReduce. No? The problem with MapReduce is this. It's really mostly I/O, disk, read. And then it's difficult to use or reuse whatever intermediate steps you did. The only way to use the intermediate step, say you're calculating the average, so somewhere you have to save something. So the only way to use the intermediate step is to actually save the data and then read it again. So that's the problem with MapReduce. One limitation. It's not really optimally using memory on the worker nodes. So with that limitation, they have this big data stored in Hadoop, trying to do whatever analysis on it using MapReduce, and then they want to do some data science on those data. I mean, you're gonna build a cluster of Hadoop just because you want to do some data science. So what is data science? It's really about using some statistical models, the good old statistical models, and then some not so new, some are new, machine learning tools. And of course, I forgot to add here, you're gonna have some visualization. So in data science, or let's just say, this too is a field na it's a bit hyped then, no? The data science thing. Data science is just plainly asking the right question and finding answers to it. No? So that's data science. So you're gonna have lots of iterations, trial and errors, etc. And if you're trying to do data science on a big data platform and you're using MapReduce, then that's gonna take you a long time. So with that limitation in mind, and then most data science team will have diverse team members. Some will be coming from the natural sciences, so they are familiar with Python, MATLAB, and Scilab. I don't know if you have heard of those stuff. And then if the team member is coming from a computer science background, so they are familiar with Java and Scala. And of course, you have to have a statistician on the data science team, so they have R. Now the problem now is how to find a way such that these team members using different tools will be talking to each other on the language or whatever platform that both of them can share resources and collaborate. No? Otherwise, if you have um, um, so with this data science team, you would have another team doing data engineering. So those guys naman, they would ingest data, clean up data, and they most likely be using Scala or Java. So in doing data science in big data, you have this messy effort of different people. So you have DevOps with their tools, and then data scientists or analysts with their sets of tools. So it's kind of a bit messy. In my experience, DevOps would always try to find a way such that whatever data they are storing on the Hadoop is like the smallest or the optimal way, and then the data scientist will just say, I don't care what kind of format as long as I can read it. No? And those two paradigm is not, you're gonna have to find a way to unite them. And if you will not follow this parang guidance, you're gonna have a data science team and data engineering team that are not collaborating. The data engineers will insist on doing everything on Java and Scala, and then the data scientists will insist on reading data in Python, on R, and unfortunately, libraries for supporting file formats in Avro or whatever is a bit not that mature yet in Python and in R. So you have to find a way to meet. Given this problem, the PyData community started doing this environment. They call it the Blaze ecosystem. So it's basically an abstraction, a reuse of whatever is existing in Python, and try to make access human. They call it Blaze increases human accessibility and not computational performance. It's not aiming for better system, but it's like creating an abstraction to whatever is existing and trying to make it more friendly for everyone. But Blaze is still in active development, so you can follow them on Blaze website. The amazing, with this lack of tools to be used for data science and big data, the limitation of MapReduce, the Spark guys, or the University of, I don't know where they came from, they have this idea of creating, maximizing memory, which is the limitation of Hadoop, and they came up with this system called Spark. And they, when they developed Spark, it's all running on Scala. But then they also created APIs for Python, and which is called PySpark, and then R, which is Spark R. So why is it popular, Spark? It's because of PySpark, wherein it allows ordinary, data scientists without developer background to use Spark. With the popular PySpark, with the popular Python syntax. So what is Spark? So it's your unified engine for distributed computing. It also has a bit of limited sets of data science libraries, but now it has SQL. So for those data scientists or analysts that are familiar with SQL, so they can use Spark SQL. For those doing streaming, there's Spark Streaming, and then of course there is machine learning libraries, so MLlib, and if you're doing graphs, there's GraphX. So these are all components of Spark. No? So now you have a tool that's faster than MapReduce, and at the same time you have a Python API for this Spark tool, which enables data scientists with Python background and R background to use Spark. So what's the idea behind Spark? it has what it calls RDD, or resilient distributed data sets. So the idea is still doing chunks, so same HDFS for architecture, but then Spark will store, once it reads those data, it stores in memory whatever it can stores. So I mean, kung malaki yung memory ng cluster mo, if you have a big cluster with big memory, then it will be able to store terabytes of data in memory. So since it's stored in memory, processing will be faster. And then it can also cache, they call it cache. You can invoke a cache method wherein it stores that particular data in memory so that you can reuse it somewhere in your data processing pipeline. So the concept of RDD. DevOps would usually use this because all data types on Spark are based on RDD. For data scientists, we have this data frame. So if you are familiar with pandas, then you're at home with data frame. And data frame is built on top of RDDs. So data frames, for those that are not familiar, it's just the usual table. You have columns and then rows, etc. In Spark 2.0, they're starting to unify yung data frame and data set na API. But for now, data frame is the most useful format for data scientists. Okay. Earlier, si Kix meron siyang carding person. In the company I'm working with, we actually have a library called carding. What does it do? So you have on the right side of this presentation, on the slide, you have everything that's being used by data scientists or analysts. They have Jupyter Notebook, they'll use data frame, and then on the left side, that's the data engineers world. That's RDD, Scala, Java, and Spark. So the way for us to meet is we have to come up with some abstraction wherein whatever DevOps do on the data, they'll do it in Scala, they do it in Java, but then for data scientists, it should be on a data frame. So that abstraction layer, we're calling it carding. What it do is whatever RDD stored is being converted to data frame. So that way, it's an easy workflow. So like, if there's a new data set, whatever the DevOps will just expose it to that layer, that line, and then we're able to access it using a data frame. Why is this important? There are lots of solutions for this. If you have heard of Facebook's Presto, so it's essential, and Cloudera's Impala, those tools are actually been developed to enable easier exploration of data, and all these tools are trying to be SQL compliant, ANSI SQL compliant. So the problem with that is you have to have a new tool called Presto or Impala. So that's another resource to be deployed. So what we did is to leverage Py4j. I don't know if you're familiar with Py4j. So essentially a Python. It's a Python library wherein from the Python program it can read Java objects through some serialization. It can also call. This is not your JSON thing. So it's really a library wherein Python can read on Java, and then whatever methods in Java can be read by Python. In fact, that's why it's faster for the Spark development team to release new versions. They are not actually recreating what they did in Scala and they implement it in Python. What they're doing is just Py4j. So whatever methods in Scala, they'll just call it in Python using Py4j. So now, with this exploitation, you have a unified data processing tool, all confined in Spark. So that's what the amazing thing about this. So DevOps can do whatever they want on Java and Scala, and then data scientist doesn't care about how they did it, as long as I can access it using data frames. Because that's really the way we work. So what is PySpark? If you go to the Spark website, you will notice that actually PySpark has a better documentation than the Scala one, although I don't know, maybe Java doc and docstring in Python is really better. So it's trying to, if you're familiar with scikit-learn, the documentation of PySpark is trying to follow that one. So what is PySpark? And essentially Spark. One thing that we have to remember is that it's doing everything with its concept of lazy execution. Tamad siya. What does it mean? Even if you have your pipeline already, unless you invoke it with some actions, it will not execute. So in that way, because of the lazy execution, it has an engine wherein it will try to find a way to optimize the query. So whatever transformation, say you're doing cast or filter, etc., unless you do an action, that's the only time Spark will execute the tasks. So these are the usual transformations. So when we say transformations, Spark will not execute immediately. So if you do an action, then that's the time it executes. So let's say you have a data frame and you want to do a filter, you will notice that nothing happens. But if you start that count, then that's the time it executes. How does it look like? Okay. I'll try to post the whole data set that I played with and then the slide on GitHub. So the first one is how you load data from whatever sources into an RDD in PySpark. And then essentially, it's whatever it's doing in Spark, parang sa baba, that's a similar thing in Python. So you read a CSV by doing an open command in Python. So in Spark, it's just Spark context and then text file. No? And then you'll have an RDD. Okay. So for those that are familiar with pandas, this is how it looks. So anyone not familiar with Jupyter? Lahat nakagamit na ng Jupyter? On one of the posts ni Jeff, he's saying na it's difficult to do production code in a notebook. Well, tama naman. No? masyadong madaming changes, no, sa notebook. So these are the tools being used in PySpark. So you can use Jupyter. Well, of course, you can use the terminal if you want. And these are the following pandas behavior. So in pandas, you can read CSV, so pd.read CSV, and then it outputs a data frame. No? It's different from this one. If you use this, the bottom part, of course, that's not a data frame. But if you load a CSV with pandas, with read CSV, you'll have a data frame. So in PySpark, there's a similar, you can actually convert pandas data frame into a PySpark data frame. So that's a distributed data frame already. So there. What are the common tools? You can do count, the usual. So in pandas, you have dot count. It's similar in PySpark, so that count. So you will notice that I'm trying to compare it in pandas, so it's familiar. The difference is when you do a dot count in pandas, it will count all the columns. It will labas niya lahat ng bilang. In PySpark, when you do a dot count in PySpark, that data frame will just i-output lang niya yung isang column, no? The logic is, di ba? If you have a table, so isa lang naman yung bilang ng mga rows doon, right? No? So that's why it's doing like that. And same thing, if you want to know what are the columns of your data frame or your table, you do that columns, so it will output a list of columns. Same thing for Spark. If you want to know the types of values on those columns, you can also use .d types. So in Pandas, you have .d types. In PySpark, it's still the same, .d types. Oh. But if you will notice, on the Spark .d types, it's returning a list of tuples. Oh. Yun lang yung difference niya. You can also do describe. So it's basically doing, unfortunately, the .describe in PySpark is not that rich as what we have in Pandas. In Pandas, you have even the standard deviation, you have the 25, 50%, 75%, 100%. In PySpark, you just have count, mean, standard deviation, and then min max. So richer yung sa Pandas. Okay. How to do selections? So in Pandas, you have your sa pinakataas, no? The difference is for PySpark, you will use dot filter. No? Dot filter yung gagamitin mo. Okay. There's finding uniques. So in PySpark, there's this dot select, dot unique, dot distinct, and then you can count. So in Pandas, you don't have this similar dot distinct. So you do your PD dot unique, and then you count the output. Okay, so medyo iba. So, group. So you can also do groups and sort. So in Pandas, the usual group by. In PySpark, the difference, you have group by na yung B, capital letter. And then, yeah, it's similar na. No? If you will notice, in Pandas, we have dot head. In PySpark, we have dot show. There's also a dot head in PySpark. No? Meron din siyang ganun. Pero the usual is dot show. Okay? Joins. So you can also do joins. So in Pandas, you can do joins, and then same thing for PySpark. The difference lang ay, I don't know, hindi niyo makita. For this part, you have data frame 1 dot join, tapos on the parenthesis, data frame 2, comma, data frame 1 dot column that you want to join, and then data frame 2 dot column that you want to join, and then how you want it, left, or right, or inner. In Pandas, you do this. So you can do this. So almost similar. No? You can do merge. Okay? Yes. Okay. So far, any questions? Na susundan pa? No? Do you need a cluster to use PySpark? May hula kayo? Actually, you can use it kahit sa local, no? What's like on my laptop, if I have to load like 16 gig of data, medyo hirap na si Pandas dyan, di ba? Pandas will find it difficult to load. It will load it. It will be able to load it eventually, but it will be a bit difficult. So what you can do, what I do is that I load the data set, the huge data set, using PySpark, so in local. And then I'll filter whatever data that I don't need. So I'll I'll have the relevant data for my analysis, and then I convert that Spark data frame into Pandas data frame, and then do everything again on do all analysis in pandas. So you can convert from pandas data frame to Spark data frame, and then vice versa. You can do that. So, as long as the remaining data set, the data frame that you are trying to convert from Spark, of course, can be handled by your memory of your computer. So you don't need a cluster to do that. In fact, you can do this. You can try to use scikit-learn using PySpark. So for example, I have this problem. Anyone who have worked with this? The LiDAR guys there. Dream pala. Have you encountered this problem? I have, say, a list or a group of coordinates, GPS, lot long. And then what I want to do is group these GPS coordinates according to proximity with each other. So for those who have encountered this problem, na-imagine nyo yung problema gustong gawin? Hindi. Na-imagine nyo? So for those who have encountered this problem, what kind of machine learning problem is this, if this is a machine learning thing? No, it's not. So parang if I have, say, 10,000 GPS pairs, and I want to group them according to proximity with each other, say, for those coordinates with 700 meters apart, then group them into one, and then another one for those. So that's the parang classic na clustering, di ba? Agree? So for this kind of problem, what kind of clustering would you think you can use? So if for those people who have worked with clustering stuff, can you do K-means for this? Huh? I don't know if you can use that. You have to think of parang these are actual distances, di ba? Meters, kilometers. Hindi ko alam kung ano yung effect pag SVM ginamit. I haven't tried it yet, though. The problem with that, paano kaya? Ano magiging problema pag SVM? How you differentiate? Kasi parang SVM, you're gonna have to, the points should be parang magnitude, di ba? Same thing for K-means. Unfortunately, hindi mo pwedeng sabihin si GPS 1 tsaka si GPS 2 ay mas malakas sa GPS 3, di ba? Parang weird. It's weird. No? So, there's this, in scikit-learn, there's this density clustering algorithm. It's just really cute. Have you seen this? Have you encountered this? This clustering algorithm is good for data sets na very close to each other yung points, very dense. No? So you can use dbscan. So in dbscan, you can define the metric. No? So if, say, you want to cluster GPS coordinates within this range, so you can do, you can assign an epsilon for it. They call it epsilon. So the distance. So for this case, since we are using GPS coordinates, what would be the definition of our distance? Kaya? Well, the usual answer would be a Euclidean distance, diba? So points. But for this one, what I did is, rather than using a Euclidean distance, ang ginawa ko ay, I use the, again for the dream team, that's Haversine. So diba? The difference of the Haversine formula, it's the same, the Euclidean distance, and then the Haversine distance is, for the Haversine formula, it's considering the curvature of the Earth. So kailangan mo tingnan kasi yun, diba? Kasi hindi flat yung Earth. So how to use PySpark for this. So basically, the idea is to cluster GPS coordinates, no, into groups according to some distance. No? The added information is those I want coordinates na within the same municipality. So isang group sila. So say CDO, all coordinates in CDO should be clustered. So ibang cluster sila. So walang coordinates, so there will be no coordinates for Davao City that will go to CDO. You get that? So that's the main problem. So how to do it in PySpark? Well, there's no sense of using this if you have a GPS coordinates list na parang, say, 1,000 lang, no? Kasi you can do it with the usual Python, no? Iterate mo lang, no? Per municipality, you iterate, you do your DB scan, no? But for this case, in our use case, it's actually clustering GPS coordinates for around 1 million na parang sub-municipality. No? So parang meron kami classification for that. So how to do it in Spark? You first load the data, so the usual, you do text file. Since this is an RDD, the way to show it is different from data frame. So for data frame, .show. For RDD, it would be .take. Now, the problem with a CSV file, of course, you're going to have the first line as, di ba? The header, yung the name of your columns. So when you do kailangan mo muna siya, you have to take that out first, right? So to do that, so you have that. Okay. So what I did is so when I read the line using the sc.text file, that line is split into whatever delimiter that I have on that line. So kaya ako may split that row. Essentially, the split that row is just you split the line into pipe because it's pipe delimited. Ganun lang yung ginawa. Okay. So you filter out whatever row that doesn't have municipality PGSC code, so because that's the header. No? So once you have that, the next thing to do is to actually create a key value pair. No? So in RDDs, you'll have that. That is, your key would be the municipality code, and then the value would be the GPS coordinate. Diba? So that's why I have the second line. What it do is, so the filter, that's filtering the row, and then the next dot map, what it does is, it designates the row 0, well, that's just the list element 0 to be the municipality code, and then whatever list index 1, and then after is the value. So with that, I'll have this. I have this tuple, the municipality code, and then a list of coordinates. So now, I have an RDD wherein the key is the municipality, and then the value is the GPS coordinates. But then, to group it, to do DB scan per municipality, you have to group all GPS coordinates of the same municipality, right? So to do that, you can do group by key, so the later part, group by key. So what it does is, it groups everything that have the same key, and then the value would be some iterable result. So basically, that's just a list, no? Later on. So ngayon, everything is grouped. All GPS coordinates within the same municipality are already grouped. Naka-group na sila. No? So once you have that, you can start doing this. You prepare those values for DB scan. So, ang ginagawa lang nito, what it does is, it assigns, so list, you have the long list of all GPS coordinates for a particular municipality. So, yung element 1 of the list would be GPS, lat long 1, then the next lat long 2, lat long, and so on. So what we'll do is that ilalagay ko lang siya sa, I just have to put them in a dictionary. You notice that? So inassign ko lang siya sa dictionary. No? The intention is, once I have a list of dictionary, I could convert it into, again, into a pandas data frame. That's the idea. No? Well, there are better ways, I think, of doing it, but I'm more comfortable with pandas. So everything, if you can convert it into pandas data frame, then well and good. So this part, what it do is it converts the list of list earlier into a list of dictionary. So yun lang yung ginagawa niya to prepare for DBSCAN. And then, once I have a data frame, I could create a data distance matrix, as they call it. In pandas, it's easy to do. Just do the .as matrix. So the pandas df2 matrix, and then this part. So essentially, creates a distance matrix. No? So may distance matrix na ako. And then, once I have that, that's where I'll use my clusters. So create cluster via DBSCAN. So what it will do is, it will get those distance matrix. So per municipality, I have a key for the municipality code, and then I have a distance matrix for all the GPS coordinates there. And then I feed it to DBSCAN. So this one. So this part essentially tells the DBSCAN algorithm to group all GPS coordinates with distance of 700 meters. So that one. And then you create, and then you count the clusters it was able to get. And this will be the output. So this is the municipality code and the number of cluster it generated. And then this is the original pairs. So parang out of the 28 GPS pairs on these particular municipalities, I was able to group them into 5. No? So that's the the takeaway there. So parang you can mix, you can actually use scikit-learn with PySpark. So if you have algorithms not present in MLlib, since it's really a bit lacking pa, no, nung machine learning libraries, you can use PySpark, but then you have to think into the world of RDDs. So you're manipulating RDDs, and then you have map functions doing all this. Malaki tulong yun, no? It's faster. Ay, sorry. Any questions so far? Okay pa? Pa ba? Wala na yata akong sasabihin eh. Yan. So yun. So the takeaway is you can have a unified big data processing, and at the same time, it's also your tool for data science using this one. No? Just don't forget that in PySpark, you can use whatever Java or Scala function on the Spark, even if it's not yet implemented in PySpark, because of the PyPorj interaction that they have. No? So you can have seamless integration. Of course, that the problem there is if you will insist on having an SQL ANSI compliant thing on the tool, then Hive, which is being used by under Spark and the Spark SQL, it's not really ANSI compliant. But then it's already reached for data for ETL, and then once you have a data frame, Spark 2.0 and up is starting to use data frame as basis for almost everything on machine learning. No? Something similar to scikit-learn. No? There, so you can have, it's possible to have a unified big data and data science platform using mainly only Spark. No? Unlike yung sa ibang implementation kasi, yun nga, they gotta use either Presto or Impala. just to get a SQL tool to query big data. No? So this one, you can exploit Py4j for that. Okay, and it's all Python. It's all Python. So in our practice, it's usually the data scientist doing all the exploration and then creating some models. Once we have a model na we seems okay na, the DevOps team will implement it in Scala. So we don't have that problem of production. Kasi yun nga, the DevOps team will take care of that, no, doing everything in Scala. So I think okay na ako. So if you have question, then marami pa tayong oras for that.
Sir, I'm just curious about like from the code that you have flashed a while ago. There's actually that map function. Yeah. I was just actually curious if PySpark have implemented its own map version of the map function in Python, because by default, Python already have its own map and filter functions. And I have seen the map and filter in the PySpark.
Yeah.
So are they implemented differently from the regular?
This is the filter function in Python.
Okay, so if you're going to use PySpark, what data structure are they actually producing? Because you can, like, after the result of applying a map, you can apply another map into it. So is PySpark producing a dictionary, or what kind of data structure are they producing after an operation?
So wait lang. Hindi ko sure kung it's the same dot filter or dot map or in Python. But if you do dot filter, no, for dot filter, it will produce whatever yung data frame mo dito. So if you have a data frame here, if you do dot filter, it will kung ano yung whatever data types here, that's the same. If it's an RDD, then if you do a dot filter, it will be the same data types as whatever is in here. If you do a dot map, that's the tricky thing. If you do a dot map, whatever you define on your map function, let's say for this one, I'm using this here, dot map, prepare for dbscan. So for whatever data types on this return part, that's what gonna come out. So for this one, it will always be a tuple. So x0, that's the key, and then a dictionary, that's a list. Because if you will notice, inappend ko lang siya. I just appended this one. So basically, it's a dictionary of list. I have that list here, right? So it's a list of dictionary. So my return will be a tuple of this one, and then, so this is just the municipality code, and then a list of dictionary. You can do that as long as you are in PySpark. Now, the problem is, if you want to save that, if you want to store that, Java or the Scala doesn't know, you have to convert that list of dictionary in Python. You have to find a way to like map it again such that it's the same thing as whatever Scala understand. Yeah. So the usual thing that I would do is convert it to JSON. So it's in JSON, Java is happy with that. Scala is happy with that. So we're good.